Hey everybody, my name is Calvin and welcome back to episode 8 of my Learn Python series. Today, we'll be covering functions. Functions are the moment where your code starts to look like real software instead, of just a bunch of lines in a file. Up to now, every script we wrote in the previous lessons ran basically top to bottom. That's fine for tiny examples, but what happens if you want to repeat logic or you want your code to be readable a week later? In that case, you need structure. Functions will give you that structure. What is a function? A function is a named block of code you can run whenever you want. You can feed it inputs or parameters, and you can have it hand you back an output. That's pretty much it. But the simple idea here pretty much unlocks everything in software engineering. You can reuse without copy and pasting, you have cleaner logic, easier debugging, and code that's naturally testable. In this video, we'll be using all the concepts that we covered in lessons 1 through 7 and wrap them into a nice bundle, that being the function. As always, the course repository is linked in the description, and I also recommend watching the earlier episodes before this for the best learning experience. Before we jump into the code, I have something I'd love to announce. Have you ever wondered how the biggest companies in the world organize, sort, and analyze their data? It's from the work of data engineers. Data engineering is the backbone of modern analytics, business intelligence, and machine learning. Data engineers in the US earn around an average of $130,000 per year, with some even making over $200,000 annually. Hi, my name is Calvin Lin, and I wrote this book because this is something that I wish I had when I first started out. From databases, data warehouses, and real-time data streams, this book will give you a great foundation to launchpad your data engineering career. This is Modern Data, from Ingestion to Production. Available on Amazon, Apple Books, and Barnes & Nobles, so get your copy today. Be sure to check out my book, Modern Data, from Ingestion to Production, available on Amazon, Apple Books, and Barnes & Nobles. Let's create a Lesson 8 folder like we've done with the previous lessons. Initialize our first file. We'll call it 8-1.py, like we have before. In this first section, we're going to build basically the core mental model for functions in one place, so we don't have to keep jumping around. The goal is to understand what it means to define a function, what it means to call it, what parameters are, and what it means to return a value. If you get this part, everything else in this video is just variations upon this pattern. The first thing to understand about a function is that defining a function does not run it. Defining a function is basically like writing down instructions for your computer and then giving it a name. The code inside only runs when you call the function. Then, in this function, we'll add parameters. Parameters are just variables that get created when the function is called, and they are filled with the arguments that you pass in. Finally, we'll add return values. Returning is how a function hands a value back to the rest of your program. While we have used printing before, printing is just showing something on the screen. However, returning is for producing a result that you can store, combine, or compare later. In this file, we'll be writing down 3 functions, one that performs an action, one that takes an input, and one that returns a value. Let's define a function called say hello. We define a function by putting the keyword def, followed by whatever you want the function to be called, parentheses, and then pass in whatever variables that you'd like to use in your function. In this case, we don't need any variables because in this function, we're just going to be printing, so we can just leave it blank, and then be sure to add this colon here, and then in an indent under the def say hello, we're going to be writing our command. This indent is important. This basically says that this code right here will run right before this line right here. So the indentations matter. So let's print the string hello. Then we print welcome to Python. You might think that this returns hello and welcome to Python, but in reality, this function will return nothing. In this case, we have 2 print statements. So all this is going to do is just print these two statements. In this case, you can't use any of the values that come out of here because they're just print statements. So what if we ran this? Would this print hello and welcome to Python? Nope, absolutely nothing. That's because we haven't called the function yet. So in order to see the print hello, we would have to actually run it, and we call it like this, the function name with open parentheses. We would call it like this with the function name and whatever arguments that you want to pass in. In this case, it's none, so we can just call it like this. Be sure that you have the parentheses. Otherwise, if you just had this, it would do nothing because you're not actually calling anything. But now, if you add the parentheses, this actually will run the function. Now, let's define a function called greet. In here, we want to have it greet us by our name. So in this case, we're going to define it like this, define greet. And then instead of passing in nothing, we want to make sure that this function greets us by our name. So we can pass in a name variable, and then we can have it print the string hello, and then we can have it be name. And in this case right here, we pass in a string variable called name, and then we can concatenate this to the hello string. Oops. So we can call it like so. And now we can pass in a string variable, say Kelvin. And so what this will do is it'll take the Kelvin and concatenate this to the hello. And if you print this, we see the correct output. Again, this doesn't return anything. All it's doing is printing. Now, what if we actually wanted it to return something? Let's do a simple mathematical function. Let's do def add. And in this scenario, we want to add A and B. And in this case, right, we'll pass in an integer A, or a float A, or a B integer, or a float. And then we can simply have it return A plus B. And we can call it like this. We'll pass in 5, and then we pass in a 9. We can separate the variables with a comma right here, and then this will return 14. But of course, this doesn't do anything because this isn't a print function. All this is doing is it's running the add function 5 plus 9, but we're not actually doing anything with this function, so nothing is printed. Now, what if we added a print statement right here? Now we're actually doing something with this value, because what this will basically evaluate to is A plus B, or 14. So this is all this is saying is print 14. If there's one thing that you remember from this section, be sure to remember that a function that prints is not the same as a function that returns. If you need a value for it later, you have to return it. If you only print it, you can't reuse it. If a function does not explicitly return something, it returns a value of none by default. So in greet, right here, even though it prints hello name, this will evaluate to a value of none. Let's move on to the second exercise file. Let's call it 8-2-py.py. In this section, I want to cover scope, defaults, and calling style. The goal here is to learn what variables exist where, how to make parameters optional with defaults, and how to make function calls more readable with keyword arguments. These are all things you will see constantly in real production code. Let's cover scope first. Variables created inside a function are local to that function, meaning they don't leak out of the function. This is good because it prevents accidental conflicts, but it also means if you want a value outside the function, you have to return it. The second is default parameters. defaults let you give a parameter a standard value so you don't have to pass it every time. This is a realistic feature you'll use whenever most calls share a common value. The third is keyword arguments. Keyword arguments let you call a function by naming the parameters. This makes calls easier to read and prevents you from mixing up the order. We'll use a simple example for all three concepts. Let's create a function called def compute total. And what this will do is it'll take a price and a tax rate variable, and it'll return the total. Let's give tax rate a default of 0.0625. So we can define it something like this, a float of 0.0625. And this is basically the default parameter here. So if you don't pass in tax rate, it automatically defaults to 0.0625. Of course, you can also pass in your own tax rate variable and have your tax rate be something like 100%, 200%, or 0%. But if you don't pass in anything, then this automatically defaults to 0.0625. Now, we'll define a variable called tax, which is equal to price times the tax rate. Now, let's notice that tax is a local variable, meaning this variable is only defined within the compute total function right here. So what if we wanted to print tax outside of the function? You'll see that outside of the function, tax is not defined, even though tax is defined right here. This is because, or in this case, tax is in only the scope of the function, but it's not in the global scope. So the print value in the global scope doesn't recognize the variable tax. Now, we can have it recognize the tax variable by putting it inside the function, like so. And you can see that it's no longer throwing an error because now that the print is inside the local scope, it can get the tax variable from right here. We'll do the same thing with a total. Total is equal to price plus tax. And then we'll have it return total. Let's test the default tax rate. So we can pass in print, compute, total, and we'll have it be 100. And this should give us $106.25 because the tax rate, we don't pass in a tax rate variable right here, so it automatically defaults to this tax rate right here. We can print this 106.25. And then let's test if we wanted to override this tax rate right here. So we had compute total. And let's say that we want a 100% tax rate. Since we're using decimals, this will evaluate to 1. 100% tax rate is 1. And then we'll see that this tax, the total, is going to be 200. Now, we can also use our keyword arguments, compute total, and then we can specifically have it be total, or price, is specifically equal to 100, and then we can have the tax rate is equal to 0.10, or 0.1. And we can have the tax rate be 0.1. This needs to go in here. And now this should give us 110. Oops, got it unexpected. Oops, this should be tax rate. See, it has to match exactly 110. The big takeaway from this section is that functions will create a clean boundary for you. Everything inside will stay inside unless you return it specifically. Let's move on to our third exercise file. Let's create a file called 8-3. Oops. 8-3.py. And in this section, we want to cover functions that make decisions and protect your code. In real programs, functions are often used to enforce rules and keep the rest of your code safe. What does that mean? Instead of sprinkling checks everywhere, you put the logic in one place. This is especially important for beginner code because it prevents errors and makes your program predictable. In this section, we're going to build two small validation style functions. The first returns a boolean so you can use it in conditionals. The second will return none when it can't produce a valid result, which is a pattern you've already seen with missing values earlier in the course. Let's define a function called isPassing. And in this scenario, or in this function, we're going to be taking a parameter called score. And we only pass if the score is greater than or equal to 60. So we can do something as simple as this. Score is greater than or equal to 60, and this evaluates to a boolean. So if we pass in a 70, this will return true. If we pass in a 50, then this will give us a false. Or this whole function evaluates to a boolean value. We can use this return value because we can directly plug it into if-else logic later. Let's verify that this function works. Is passing. So if we pass in a 60, although it's on the cusp, it should pass. True. But if we pass in a 50, or even just a 59, not 590, we'll get false. Let's define a function called safeDivide. And this function is going to help us prevent unsafe division. So if b is equal to 0, as in you can't divide by 0, we return none. And then we can print if b is equal to 0, then we return none. Because if right here, we can't divide a by 0. So we can have it print an error. And if this check doesn't, and if b is not equal to 0, then we can do our division safely. A divided by b. We can test this. Print safe divide. Pass in 10 and 2. This should give us 5. It goes 10 and 2. Replace the variables b and a in here. Passes this check. A divided by b. Now, if we pass in 10 and then a 0, we can't divide 10 by 0. So this should give us none. Because it goes into this conditional and it returns before it ever reaches this. The point here is that functions don't kind of just compute. They also will enforce rules and handle your edge cases in one place. So the rest of your program will stay clean. Also, one thing I wanted to mention, or one thing that's really important, is you can only return once in a function. So in this case right here, this is the perfect example. Because if b is equal to 0, we go here and we return none first. So that means the function will only ever return none. It won't return two values because we'll never ever reach here. Because as soon as it hits a return, we're out of the function. And none of the code after that matters. Let's move on to our next section. Let's call this 8-4.py. In this section, I want to cover using helper functions with loops and lists. This is where functions kind of start feeling like a tool that you can actually use. The goal here is to show a real pattern. When you have a loop doing work on many items, the loop should stay simple. The how do we process one item logic should simply go into a helper function. What does that mean? let's define a function called clean name. And what this will do right here is take in a name string, and it'll help us clean the string. So we pass in name, and then we strip any trailing white spaces, trailing or preceding white spaces, and we'll keep it lower. And we'll keep it lowercase. So if we pass in, this should be clean name. Again, the function name has to match exactly, or the program's not going to know what you want to do. And we can pass in Calvin, have a bunch of extra stuff here, and let's print and see what this gives us. This, if we've done it correctly, this will just give us Calvin, all lowercase. And we see that we've done it correctly. Now, what if we had a list of raw names? Say we had this string right here, this messy Calvin string right here, and then we had a, oops, don't do that. We have Ava, well, uppercase. And we'll have John with a single space. And we can have Paul. Now, what if we wanted to take the raw names and process every single item in the list with clean name? Rather than writing clean name out 4 different times, what we can do is simply loop through raw names and apply the clean name function on every single value in the list. So we can do for name in raw names. We can apply the, let's create a new list for a resulting list, or after we've cleaned all the values right here. And we can iterate through raw names, apply cleaned names function on each one. So we're going to append every single value that we get from this loop into clean names. And we pass in clean name. And what this will do is, it'll, for every value in raw names, it'll apply this line of code until we run out of values in the list. And let's see what cleaned names looks like afterwards. So after we run this for loop right here, we apply this function, this line of code on every single value in raw names, and then we append it to cleaned names. And as you can see, we get Calvin, Ava, John, Paul with the clean name function applied on every single one. Now, it may not seem like all that much to write down clean name 4 different times for each one of these values. What happens if our raw names list is, say, 50 values long? In that case, right, we would have 50 lines of code compared to 2 lines of code, because this will just iterate through every single one of these values. We can also do the same thing with a def count greater than function that takes in numbers and threshold. Is a little bit more complicated of a function. We have count is equal to 0 for n in numbers. If n is greater than threshold, then our count is equal to count plus 1. And then we'll return count. Say we had a nums list with 2, 7, 4, 9, 10, and 3. Now we can call the function count greater than and then we pass in our nums list, and then we can pass in a threshold of 5. And in this case, since it takes in the whole list here and it applies the threshold comparison, we can get 3 because we know we have 3 values in here that are higher than the threshold that we set of 5, that being 9, 10, and 7. Now, if we want to do the same thing, and we pass in our list the same way, and say we had a threshold of 9. In this case, we'll expect only 1. And that's what we get. Since we've gone long enough, I think I will make this into 2 parts. Be sure to check out part 2, coming soon. There's a lot more to cover in functions, and I don't want to rush covering functions because, again, this is the baseline or foundation for all software engineers. You have to understand this, so I don't want to rush it. So be sure to hit the bell notification to get notified of the next part coming out. As usual, we'll do git add lesson 8, and then we'll commit this. And then we'll do git push. And now this is saved to our course repository. Thanks for watching, and I'll see you guys in part 2 of lesson 8.